Today we will see how to do multiplication and division of binary numbers. The first one is multiplication of binary numbers. So here what we do is, suppose you have two numbers A and B. You want to multiply A with B. If you're simply given two binary numbers, you just have to multiply it straightforward just as you do in the case of decimal multiplication. Let's see how we do that. We have two numbers 0100 and 1101. You need to multiply it. All you have to do is multiply it digit by digit exactly as you do in the case of decimal multiplication. So 1 into 0 is 0 itself. Then 1 into 0 is 0 again. Then 1 into 1 is 1 and 1 into 0 is 0. The next is 0. When you multiply with 0, everything becomes zeros. Shall I get 0, 0, 0, 0, 4 zeros. The next one is 1. So when you multiply it with 1, I get 0, 1, 0, 0. That is shift and 0, 1, 0, 0. Correct. The next one is also multiplying by 1. So I get 0, 1, 0, 0, 0, 1, 0, 0. Right. When I add this, what do I get? 0, 0, 1 plus 0 plus 0 is 1. Here it is 0 all over. 0 plus 1 plus 0 is 1. And here it is 0 plus 1, 1. And finally you have 0 again. So this is your final answer when you multiply these two binary numbers. This is pretty straightforward, exactly as you did in the case of decimal arithmetic, no other changes. But what if the numbers are given to be signed numbers? In such a case, suppose I have two numbers 0010 and 1010 and I am told that they are using signed number representation. It could be any of the three forms, 1's complement, 2's complement or sign magnitude form. Suppose it is 1's complement form. If it is 1's complement form, I understand the first number is actually positive and the second number is negative. So I need to deal with the sign of the result. Is that right? So 5 into minus 2 is minus 10. 5 into 2 is 10. The value of both these numbers is same. Only the sign is different. So the first thing you need to do in multiplication is take care of the sign. So when you have two numbers A and B, the first thing you do is make sure that both the numbers are in their true and uncomplemented form. That means 0010 is 2 for certain and 1010, if you are following 1's complement method, it is 0101, which means it is 5 minus 5. Okay, so I have 2 and minus 5. So I have to convert it into the true uncomplemented form, meaning the numbers become 0010, it is the true form, and 1010 has to be converted to 0101. These are the two uncomplemented forms. So we are given 0010 and 1010 and you're given that we are following 1's magnitude, 1's complement sign form. So 0010 indicates a positive number. 1010 indicates a negative number. Therefore, my result will be, since they are of different sign, when you multiply plus and minus, I get a minus. Therefore, the result will be negative. Let us make a note of that. The next step, as we just discussed right now, is to obtain the true and uncomplemented forms. Let us take the true and uncomplemented form of the first number. Since it is a positive number, the number itself is already in the true and uncomplemented form. The second number is a negative number, indicated by this 1. So 1010 tells me that it is a negative number. To obtain the true form or uncomplemented form, I just have to take the 1's complement of this number back again. What is the 1's complement of 1010? 1010. I have to take the 1's complement back and I get the original true uncomplemented form. So 1010 becomes, invert the bits bit by bit, 0101. Now I've got the true and uncomplemented forms of both the numbers. Next thing I have to do is multiply these two. When I multiply with 1, I get the number itself, 0010. Multiply 1 with each of these numbers, 1 into 0, 0, 1 into 1, 1, 1 into 0 and 1 into 0, 0, right? When I multiply any number with 0, I get 0 itself. So when I multiply with 0, it becomes 0, 0, 0. All the 4 bits become 0. Next I multiply with 1, I get the first number itself, 0, 1, 0, 0. The first number is called the multiplicand and the second number is called the multiplier. Again multiply with 0, 0, 0, 0, 0. The multiplier bit is 0, and the multiplicand is 0, 0, 1, 0, but multiplication with 0 is resulting in 0 itself. Next, you add it, just as we do in decimal. So 0 plus 1, 1. Here it's all zeros. Here I have just a single one, 0, 0, 0. What is my result? My result is 0, 0, 0, 1, 0, 1, 0. The zeros on the left hand side do not add any value to the number, only the ones add value to the number. And if you check the value of this number, you will get 10. I already know that the result is negative as we have observed here. Therefore, I add the negative sign here. That is why my result is minus 10. Suppose the given numbers are signed numbers, but it is in 2's complement form instead of 1's complement. In that case, we follow the same procedure exactly, but except for this part where in order to get the true and uncomplemented form, you found the 1's complement. Instead of that, you do 2's complement. Everything else remains the same. So that is how you do multiplication if the given numbers are expressed in 2's complement signed form. Okay. So in this way, whichever signed magnitude form or 1's complement or 2's complement you are given, follow the exact same procedure. Just be careful on how you obtain the true and uncomplemented form of the negative number. So that's how we do multiplication of binary numbers. Next we come to division. How to do division? Suppose I have two numbers A and B and you have to divide A divided by B. A is the dividend, B is the divisor, and what you obtain is the quotient. R is the result of the quotient here. The first thing we need to do is ensure that both the numbers are in the true and uncomplemented form. So if A or B are present in the negative number in the 1's complement or 2's complement form, then it is a negative number and you have to convert it into the true or uncomplemented form. Then note the sign. Just as we did for multiplication, note the sign. If both of them have the same sign, then the result is positive. If they have a different sign, the result is negative. Now, let us come to exact steps of how to do division of two numbers. Before we do the actual division in binary numbers, let me explain to you, or let us recall the basic concept of division itself. How is division performed? Suppose I have two numbers and I want to find the quotient and remainder for those two numbers. 15 divided by 5. In this, 15 is called the dividend, right? And 5 is called the divisor. We already know that. And we already know that 15 by 5 is equal to 3. How did we get this 3 basically? Actually, division is repeated subtraction. You want to find out how many 5s are there in 15. So you remove one 5 at a time from 15. Okay, you remove one 5 from 15 at a time. So 15 minus 5 is 10. Okay, what is 15? Dividend. What is 5? Divisor. Correct. What you got here is actually what is remaining, and let me call it the remainder. But is this the final remainder? No. Therefore, I will call it the partial remainder. Let me call it the partial remainder, 10. So how many 5s did I get here by subtracting 5 from 15? I got 1 5. So let me call this is the quotient. Okay. Currently, there is 1 5 in 15. That much information I got. Let me remove one more 5 from the partial remainder. So this is my partial remainder now, 10, and I subtract another 5 from 10, and what do I get? 5. So the quotient becomes 2. What does the quotient tell me? It tells me how many 5s are there in 15. So as of now, I know that there are 2 5s in 15. Correct? So 10 minus 5 is 5. This is our new partial remainder. So let us find out if there are any more 5s in the new partial remainder. This is my new partial remainder. Are there any more 5s? Let me subtract 5 from it. 5 minus 5, I got 0. Yes, so a complete 5 was present in it. Therefore, my quotient becomes 3. At this stage, all of us know that we need to stop. Why? Because there cannot be any more 5s in this remaining amount. It is 0. So if you get either 0 or negative, you know that there are no more 5s in that case. Okay. So what is the quotient that I got here? 3. What does the 3 tell me? It tells me that there are 3 5s in 15. In binary division, these are the steps that we will follow. What are the steps that we just read right now? we started out with the dividend, correct? 15 is the dividend. I subtracted the divisor from it and I got something called the partial remainder. Since it is positive, I denoted the quotient as 1. Again, I take the new partial remainder 10 and I subtract another 5 from it. Yes, I got a positive number, so there are 2 5s in it. Correct. Again, I took the partial remainder. This is my new partial remainder. Subtract a 5 from it and I got a 0, which means there is an entire full 5 inside the partial remainder again. So I got my quotient as 3. I cannot remove any more 5s from it, and therefore my final answer for quotient is 3 and the final answer for remainder is 0. Correct. Let us follow the same steps for the binary division. The first step, of course, is to ensure that both are in their true form. So we do that. Ensure that both are in the true form. Initialize the value of q to 0, just as we did in 15 divided by 5. Initially, quotient is 0. Then you initialize the partial remainder equal to dividend. In case of 15 divided by 3, which we did just now, the partial remainder is equal to 15 you start. And from 15 you keep on subtracting 5. That's what we see here. PR is equal to PR minus divisor. That means the new PR is equal to 15 minus 5. And you got 10. And the next new PR is equal to 10 minus 5. And the new PR is equal to 5 minus 5. So you keep on doing partial remainder minus the divisor. Correct? And for each subtraction you have to increment the value of q. Q becomes 1, 2 and 3 until, how do you do that? Until the partial remainder is either negative or 0. And then at that point you stop and take the current value of q at that point and the r value at that point. Okay. If it is the case of negative, you have to take the r value from the previous step. Okay. So that is how we do division for binary numbers. Let us do a problem to understand this. 15 divided by 5. In this case, 15 is the dividend and 5 is the divisor. And the numbers will be given in binary form. So the dividend is equal to 0, 1, 1, 1, 1. And that is given to you. Divisor is given to be 0, 0, 1, 0, 1. First step is initialization of PR and Q. Initialization, PR is equal to 0, 1, 1, 1, 1. That is a dividend. And Q is equal to 0. The step 1. After initialization, you do PR equal to PR minus divisor. What is PR? 15. Minus divisor, 5. When you subtract it, you get 10. That is 0, 1, 0, 1, 0. And from this, you understand that it is positive. Correct. So this is your new PR. And since it is positive, you increment the value of Q. You get Q equal to Q plus 1. That is 1. You use the new PR here. That is 0, 1, 0, 1, 0. And subtract divisor from that. Again, you get 0, 0, 1, 0, 1. Subtraction can be done using direct subtraction method. The new value of PR is again positive, as you can see here, and therefore you can increment the value of Q. Q equal to Q plus 1, that is 2. Now you have got the new PR. Again, since it is positive, you can keep going. Next step is again PR equal to PR minus divisor. So 5 minus 5 is what you get here, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1. If you subtract 5 minus 5, you get 0. Since it is 0, you stop. And what you got here is a final remainder. Increment the value of Q and stop, and that what you got is the final quotient. So final remainder equal to 0, final quotient equal to 3. Let us see a case where you get the partial remainder as negative. Suppose you do 15 divided by 6 just like we did earlier, 5-bit representation, dividend, divisor, initialize, and you get partial remainder here. This is positive because the first bit is 0. Increment Q, you got 1. Next, once again you are doing PR equal to PR minus divisor. You get the result here and you see that it is positive. This is your new PR. Okay. Therefore, you can increment the value of Q. Finally, you come to step 3 where you do PR equal to PR minus divisor and you get 11101. That partial remainder is negative. If you see negative, don't increment the value of Q. Take the previous value of Q. So the final value of Q is 2, as you see here. So 00010. And the final value remainder is the previous value of PR. Previous value of PR was 00011. That is 3. 00011. That is the final answer. So this is how we do division in case of binary. I hope it is clear to you guys. Okay. So please work out more problems. Thank you. Bye.